chapter 4, and this first section of chapter 4 is a really important idea going forward. It's something that comes up kind of over and over and over again. It becomes a core part of what we're going to be doing in future chapters. So if there's a day to kind of bring your A game attention-wise, this would be a good one. All right. So I'm just going to give a little bit of background before we dive into doing things computationally as to what's going on. So I'm just going to kind of do this graphically and kind of talk about what we're doing. Is that okay? So let's say we want to talk about the inverse sine function. So let's start by just thinking about what the graph of sine looks like. This looks familiar, right? We just talked about the graph of sine. To find to graph the inverse of this, what do? Swap the x and y coordinates, right? So if I do that, this is what I get. What do you notice about this blue graph? Anything stand out to you? It's not a function. Why not? Yeah, it fails a vertical line test. Is that a problem for us? It is if you want to make a calculator function to do this, right? Do you remember what we said we do, or what we can do to take something that fails a vertical line test like this? How do we take a function whose inverse is not a function? We can do something to that function so that the inverse will be a function. Do you guys remember what that is? I think we talked about it briefly. So the goal, what we're going to do is we're going to restrict the domain. So we're going to go back to our graph of sine, and we're going to restrict our domain so that sine is 1 to 1, so that it has no repeated y coordinates. So we're going to start here at negative 0.5 pi and go to positive 0.5 pi, and we're going to discard everything else. Everybody's okay with that? Oops. So that's the green graph now that we can see. Notice that green graph covers the entire range of sine. Everybody agree? But it doesn't repeat any y coordinates. So that's a good one. That's what we're going to use to create our inverse. So if I take that graph now and swap its x and y coordinates, what I get is this yellow one. Let's pick a different color though, huh? I'll do purple. Oops. That wasn't the one that I thought I was doing purple of. Okay. Let's do that. Try that one more time. So this one we wanted teal. That one was that. Oh, there it was. I just had it. Maybe I didn't get it. There we go. Ah! All right, whatever. Here's what we'll do. Hide. There. So there's my yellow one. That's my graph for sine inverse. Everybody's okay with that? Notice it's a function, right? What's the problem though? My set of outputs here go from negative pi over 2 to positive pi over 2. Can I have sine of angles bigger than those or smaller than those? Yeah. So we're going to have to do some adjustment to kind of make this work in any case. But that adjustment we can handle on our own. We don't need the calculator really to do that for us. But to actually go backwards from sine of really any angle, we're going to use the calculator. All right, so that's kind of the idea of how we're building out these inverse trig functions, is they're all going to come from restricted domains. So for y equals sine remember here, the domain for sine was all real numbers, but we restricted it down to negative pi over 2 to positive pi over 2. And its range was negative 1 to 1. So when we created our sine inverse, the domain for sine inverse is the range from our restricted sine function. And the range for sine inverse is the domain from our restricted sine function. Everybody's okay with that? That information is important. You do need to remember what the range is for sine inverse. That becomes quite important. We'll do the same thing now for cosine and for tangent. Although when we restrict the domain for cosine, we're going to do that differently. Why is it going to be different? Well, come on, Mr. Gulick, it's because the shape of cosine is a little bit different. All right, Mr. Smarty Pants. You're right. So again, the domain for cosine inverse will be the range for cosine. And the range for cosine inverse will be the domain for the restricted domain for cosine. And do the same thing for tangent. Now remember, what's tangent? The domain was all cuckoo crazy, right? Oh, what was it? N over pi. Ugh, I can't remember anymore. Did you ever have one of those days where you just like not sharp at all? Ooh, that is today. Okay. That's it. There we go. We're going to restrict that down to just here. Notice that I used parentheses here for tangent instead of brackets. Why did I do that? Why did I use parentheses instead of brackets? Anybody with a guess or a no? You could know the reason. Katie. That's where the asymptotes are, is at negative pi over 2 and positive pi over 2. Very good. So those aren't in the domain anyways. So they get parentheses instead of brackets, right? Bracket means included. Parentheses means it's not included. Okay. So depending on how we ask a question here, it's going to dictate where we're going to be looking for our angle. So let's do some examples, eh? So let's say we want to find the exact value of sine inverse of negative 1/2. What's the range for sine inverse of negative 1/2? Negative pi over 2 to positive pi over 2. That's what we just wrote down a moment ago. That's why that matters. What angles or what quadrants do angles between negative pi over 2 and positive pi over 2 lie? Where do those lie? What quadrants? Well, a standard position angle, a 0-degree angle starts here, right? If we rotate counterclockwise, pi over 2 is there. So this is certainly quadrant 1. Everybody cool with that? And remember, to get negative angles, we rotate clockwise. And this spot down here would be negative pi over 2. So I'm looking for my answer as an angle in either quadrant 1 or quadrant 4. Everybody's okay with that? Now, if my angle is like theta equals sine inverse, that's the same thing as saying sine theta is equal to negative 1/2, right? That's just like what an inverse means. Everybody's cool there? Is sine negative in quadrant 1 or quadrant 4? 4, because remember, sine is the same thing as the y on our unit circle. And the y coordinates are negative in quadrant 4. They're not negative in quadrant 1. So I know my answer is there in quadrant 4. Everybody's cool? So I'm going to go to the unit circle. And I'm going to look in Q4 where the y coordinate is negative 1/2. So far, so good? Let me go grab that unit circle and drop it in here. Boop. Bloop. Everybody's good? So my answer then should be 11 pi over 6, right? Is that right? No. But Mr. Kulik, we just did exactly what you said. Well, the problem is that angle is not between negative pi over 2 and positive pi over 2. Oh no! What are we going to do to find an angle that gives us an equivalent answer that does lie between negative pi over 2 and positive pi over 2? Find an angle coterminal to it. So I'll be adding or subtracting 2 pi, or 360. In this case, since we have a radian answer, we'll do 2 pi. Is 11 pi over 6 too big or too small? Too big. So should we be adding 2 pi or subtracting 2 pi? Subtracting 2 pi. When we do that, we get negative pi over 6. And that, my friends, is the correct answer. Point of order, you could have also thought about it just on the unit circle, been like, oh, well, I'm going this way. So that's just like going from 2 pi to 11 pi over 6. I just went pi over 6 in the negative direction. So you could have looked at it and just done that as well. Is everybody cool with that? That requires some mental math, so I don't like to start with that way. But it is the same thing as what we're doing, right? Is that okay with everybody? Okay. What if we ask the same question, or almost the same question? So find the exact value of theta equals sine inverse of 1/2, where theta is equal to between 7 pi over 2 and 9 pi over 2. Okay. Well, my first question is, what quadrants are we looking at here? So I'll draw myself a picture. So let's see, this is pi over 2. And then we're down to pi. And then to 3 pi over 2. And then to 2 pi. And then to 5 pi over 2. And then to 3 pi. And then to 7 pi over 2. Hey there! And then to 4 pi. And then to 9 pi over 2. Great! So what quadrants did we cover? 1 and 4. Is it always going to be 1 and 4, Mr. Kulik? No, it won't always just be quadrants 1 and 4. Everybody's cool with that? Yeah. Just like we said before, this is equivalent to saying sine inverse of negative 1/2. Sine is negative only in quadrant 4. So we go to the unit circle. We look in Q4 for where the y coordinate is negative 1/2. Well, that was the same spot as before at 11 pi over 6. Is that our answer, though? No, because it doesn't lie in the interval. Is it too big or too small? Too small. So this time we're going to add 2 pi to make it bigger. When we do that, what do we get? 23 pi over 6. Good mental mathing. Is that in there? Well, this is 21 pi over 6. And this is 27 pi over 6. Yes. So we should be good. What do you guys think? It's not too bad, right? Okay. What if we change this a little bit? What if we have find the value of theta where theta equals tan inverse of 1.75 and theta is between 3 pi over 2 and 5 pi over 2? You're welcome. Take care. Well, we're going to start the same way still. The beginning does not change. Everybody's cool? Notice that there is a little piece different in our instruction, though. What piece of direction is different? Exact value, right? Do you see exact value here? No. What does that mean? I can't do this with the unit circle. I'm going to have to use the calculator. That's basically what that's going to tell me. All right, but we'll start the same way. We're going to start by figuring out where or what quadrants 3 pi over 2 to 5 pi over 2 lie. So that's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 to 5. Let's change this, huh? I keep giving the same spot. Doesn't really matter. Let's make this from like 3 pi to 4 pi, right? Just for grins. So that's 1 pi, 2 pi, 3 pi, and all the way here to 4 pi. Everybody's okay? So what quadrants did we cover? Quadrants 3 and quadrants 4. Okay, remember this is the same thing as tan theta equals 1.75. So where is tangent positive? Remember on the unit circle, tangent is y over x. That's going to be positive in quadrant 1 and quadrant 3. Everybody agree? So quadrant 3 in this case is the only possibility that satisfies both pieces. So I know that my answer, what I'm looking for, is, well, let's draw it in a different color, is down there somewhere, right? Everybody agree? Prater? Oh, I didn't know if you was that, I couldn't tell if that was a hand. Okay. So, what's that angle theta look like? Well, we go around one time, and then around again so that we're between 3 pi and 4 pi, right? Everybody's cool with that? All right. So what I'm going to do is I'm going to look at two relationships. I'm going to look at the relationship between the last part of the x-axis. Well, actually, nope. I don't want to say that. What do I want to say? Okay. So this is my angle theta. I'm going to look at the relationship between this angle theta, the angle formed between the terminal side of theta and the x-axis. I'm going to call that angle phi. And then the part of the x-axis that makes up that angle, or the other part of the x-axis that makes up that angle phi. Everybody's okay with that? So those are the three things I'm going to be using to write my equation of how to do this. So first I'm going to do is I'm going to compare angle theta with that part of the x-axis. Is angle theta bigger or smaller than 3 pi? It should be bigger because it goes past 3 pi, right? Everybody agree with that? If it was smaller than 3 pi, it would have ended over here and wouldn't have got to 3 pi yet. So theta should equal to 3 pi plus how much? Well, this angle phi. So all I need to do now is calculate how to find that angle phi. Everybody cool? Once I can do that, I can find theta. This is the way that we'll calculate phi. It's going to be whatever the inverse function was of the absolute value, and that's it. And that'll give us our angle theta. So phi is just going to be, in this case, tan inverse of the absolute value, 1.75. Now, did the absolute value matter in this case? Well, no, Mr. Kulik. So into my calculator, I'm going to check to make sure I'm in radian mode. Because typically, well, the way we did set this problem up, we're using radians because I used radians on all these pieces. Typically, we'd ask for an answer in radians for a problem like this. Although you could ask for a problem in degrees, and all it would change is you'd use degrees on your axes and degrees in your calculator, and it'll be fine. So that gives me 10.48-ish. I want to point out two things to you. If I wanted to check this, I would need to do two things. Well, first thing I should do is check to make sure tangent of 10.48 gives me 175. Well, that's good. And the second thing I'd want to check is to see that that 1.48 is between 3 pi and 4 pi. So 3 pi is, well, certainly bigger than that. 4 pi is definitely smaller than that. I'm satisfied that I have the correct answer here. Everybody agree that it meets the criteria of the problem? Because tangent of that angle does give us 175, and that angle does lie in between 3 pi and 4 pi. Let's do another one like this. This is typically the most challenging type of problem here. Again, the way I like to do it is drawing these pictures. because I think it's really informative and it's a very helpful skill to have. All right, let's do another, right? We'll just, okay. Cosine inverse equals negative 0.81, and let's see, we'll go from 5 pi to 6 pi. Actually, let's do 6 pi to 7 pi. Okay. What quadrants is 6 pi to 7 pi? Can anyone do that in their head? Should be 1 and 2. Everybody agree? Since 0 pi to 1 pi is quadrants 1 and 2, if I'm going even to odd, they all should be quadrants 1 and 2. If not, draw your picture. Promise you that's correct. And what quadrants is cosine negative? Remember, cosine is the x-coordinate on the unit circle. What quadrants is the x-coordinate negative in? 2 and 3. So where is our answer at then? Has to be quadrant 2. The only one that agrees with both of them. Okay, so I'll sketch myself a little picture here. Initial side, terminal side. Now draw my angle theta. So 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. Well, not quite 7 pi, right? That would be what comes next, though. Everybody's cool so far? Again, my angle phi happens between the terminal side and the x-axis always. So if I look at this example, is theta bigger than 7 pi or smaller than 7 pi? Smaller, right? It doesn't quite get to 7 pi, so it has to be smaller. How much smaller is it? Phi smaller. And how do we calculate phi? The absolute value of, or cosine inverse of the absolute value, negative 0.81. Now, when I type this into my calculator, you know what Mr. Kulik's not doing? He's not going to type in the absolute value. He's just going to do the absolute value part in his head. Because for the love of Pete, that's way too many buttons to get the absolute value to pop in there. So that's about 21.36. And we should check. So cosine of that answer does give me negative 0.81. 6 pi is smaller than that. 7 pi is bigger than that. So I'm convinced that is the correct answer. How you guys feeling? Okay. Is it always the same way? Well, there's one tricky thing that can happen. Let's show you a tricky one. theta equals. Okay, then I just have to be a little bit careful here. All right. So find the value of theta when theta equals cosecant inverse of negative 1.65 and negative 5 pi over 2 is less than or equal to theta, which is less than or equal to negative 3 pi over 2. Two things actually kind of tricky going on here. First thing that's probably most obvious, Mr. Kulik, I can't type cosecant inverse into my calculator. I don't have a cosecant inverse button on my calculator. Oh, is that what you're worried about? Well, we can take care of that. Cosecant inverse of negative 1.65 equals theta is the same thing as cosecant theta equals negative 1.65. Remember that cosecant is the reciprocal of which trig function? Sine. So I know 1 over sine theta is negative 1.65. If I flip both sides of my equation, then I know that sine is equal to negative 1 over 1.65. And if I apply the inverse, then theta is sine inverse of negative 1 over 1.65. There, that problem's solved. I've rewritten that in terms of something I can type into my calculator. What do you notice if I'm just comparing this with this? If I don't want to go through all that steps that I just wrote, what is all that I really did? I just made the reciprocal of the part inside and swapped it out for the reciprocal of the inverse function, right? So do you need to show all that algebra in between? Nah, man. But that's why, right? That's why you flip it. Everybody's okay? All right. Let's continue on, because whatever the other odd thing is, Mr. Kulik says there's something tricky going on here. Maybe it's not totally obvious what it is right away. So we will need to figure out then what quadrants negative 5 pi over 2 to negative 3 pi over 2 cover. So we're going clockwise. So negative pi over 2, negative 1 pi, negative 3 pi over 2, negative 2 pi, negative 5 over 2 pi. So which quadrants are we looking at here? Quadrants 1 and 4. Of those, where is sine negative? Well, sine is negative in quadrants 3 and 4. Oops. So we want quadrant 4. So far, so good? No big deal, right? Okay. So initial side, terminal side. We'll draw our angle theta. So there's negative 1 pi and then a little bit more. So there's my angle theta. There's my angle phi. Mr. Kulik, I still don't see anything tricky here. All right. Is angle theta bigger or smaller than negative 2 pi? It's smaller. But Mr. Kulik, it went past negative 2 pi. That's right. Getting more negative, making it smaller. Ugh. So, how much smaller than negative 2 pi is theta? It's phi smaller. That was the other tricky part, is I can't tell you, in my experience, half or more of students mess up that past the negative number actually is getting smaller, so we need to subtract. Woof! All right, and then everything else is the same, right? Okay. So there's my answer, negative 693. Let's check that real quick. I'd like to point out too that let's see. So we'll do 1 over, I'm going to check actually back here. So I'm going to check to make sure that 1 over sine of that angle gives me negative 1.65. Why am I doing it there? Because if I tried checking with this one, I don't know what 1 over negative 1.65 is. That's going to be some kooky looking decimal. I'm not going to know it on site. I'd have to type in my calculator and double check to make sure that decimal is the same, which is just like an extra step that I don't want to have to do. But that part looks good. Then I just need to make sure that it is bigger than negative 5 pi over 2. Oops, that's not pi. That's pi. So it is bigger than that. Great. And then it's got to be smaller than negative 3 pi over 2, which it is. So I feel pretty good about this. What do you guys think? Not too bad, right? The picture really helps. I'm a visual guy. I like drawing the picture. I find I almost never make a mistake when I draw the picture because I have something to look at and go, wait a minute, that doesn't make any sense. When I do make a mistake, I catch it, as opposed to trying to do it all algebraically without a picture. It's difficult sometimes to tell if you're making a mistake or not. I really encourage you to draw the pictures. I'm going to draw the picture every time we do one. All right, a couple more examples from this section of other things I might ask you to do. But this skill that we just looked at is the core skill that we need to be able to do. Okay, this pops up again and again and again all throughout this chapter, or this semester and next semester. If you can effectively find the inverse value, it's going to be there's going to have lots of struggles later. So get good at it now. As an aside, that topic will be the topic of the first homework quiz, this chapter, which might be a good idea to be prepared for pretty soon. Next class would be the soonest you could possibly be prepared for it. That would be a good idea. All right. There's 2 other example things that I want to show you. So what if I wanted to do cosine inverse of tangent of 45 degrees? Well, you'd want to start from the inside out. So that does involve evaluating tangent of 45. When I go to the unit circle, I locate 45 degrees. I know that tangent is y over x. Scroll back up here. Grab another copy of this guy. Whoop. So it's going to be y over x, which is 1. Everybody good with that? So what do? Is I'm looking for this on the unit circle. I'm looking for x equals 1 on the interval from 0 to pi. Why 0 to pi? That's the range for cosine inverse, the fundamental range for cosine inverse. If you're not told what the range is, that's the range. It's coming from the fundamental values. So cosine between 0 and 2, or 0 and pi. Sine between negative pi over 2 and positive pi over 2. Tangent between negative pi over 2 and positive pi over 2, not including negative pi over 2 and positive pi over 2. So, going and looking at my unit circle. There's the x-coordinate equal to 1. 0 degrees. That's in the interval that I need. I'm done. No big deal, right? Just an extra unit circle step on the inside, and then it's just like the problems we did at the very start. Okay. One more. Actually, before we do that, I need to address a piece of notation. So sine inverse, cosine inverse, tangent inverse, etc. Another notation for that is arc sine, or arc cosine, or arc tangent, etc. So they just mean the same thing. It's another notation. We love doing this in math, right? It's like, why can't we just all agree to write it one way? Well, because some other place had been writing it the other way for 150 years and like doesn't want to change. So we're stuck with a bunch of notations, which is fine, right? In English, you got like 1,000 things that mean good, right? It's all the same. Okay. That being said, let's use that alternate notation right here in this problem. So let's say we want to find an algebraic expression for sine of arc cosine of 2x. Everybody cool with what this is asking? Now, it's asking for an algebraic expression, so I'm going to have x's in my answer, which is fine. It's not going to be numeric. It's going to be a variable expression. So what I'm going to do is I'm going to start with this. So I remember that arc cosine just gives me an angle value, or an angle measure. And then from my rules of inverses, this is the same thing as cosine theta equals 2x. Everybody agree with that? I'm going to use that now to construct a right triangle. I'm going to label one of the angles theta, doesn't matter which one. I remember that cosine is adjacent over hypotenuse. So I can label the adjacent and hypotenuse sides accordingly. And I can use the Pythagorean theorem then to solve for the opposite. Everybody could there? Now, this is the side length of a triangle, correct? So what can I do with that plus or minus? And drop that and just call it positive. So now, what do we have here? I'm just going to do sine of theta, right? That's all I'm really doing now. I'm just going to use that triangle that I've built to do sine of theta. So just 1 minus, or the square root of 1 minus 4x squared. And I'm done. So I'm just using the inside to generate a right triangle, and I'm using my right triangle trig definition to get the outside, or using the outside and the right triangle trig definition to get my expression. That's it. Is that okay? Not super confusing, although the first time you see it, it's like, what in God's name would I do with this? But it's just like, yeah, just use the inside to make a triangle, and then you just do like sine, cosine, and tangent on your triangle. Sound no big deal. What do you guys think? Does this seem okay? Alrighty. Well, that's as much as I want to do today. So you guys should be able to do up through 18. And you guys should be able to do worksheet 1, 2, 4. That'll be it for today. And this stuff is due not till Sunday. Of these, in preparation for the homework quiz, I would most be interested in finishing worksheets 1 and 2. Those would be the ones that would be the most applicable, the things that I would want to do first if I were you. Chanel?
Oh, sorry. Sunday's the 30th.
Oh, thank you. I'm just a day ahead or behind or whatever that means. Thank you. Everybody happy? I mean, happy enough? Feels like a good place to stop. Do you guys agree? Yeah. That was good today, right?